Here's problem 1326. Planet Rotan has a mass of 4 times 10 to the 23 kilograms and a radius of 2 times 10 to the 6 meters. With what speed should a space probe be launched from the surface of Rotan so as to achieve a maximum distance of 3 times 10 to the 6 meters from the center of Rotan? Alright, if we launch from Rotan, we're going to be launching from the radius of the planet, and we're going to achieve some new distance that is 3 times 10 to the 6 meters away. So that'll be our R2. This will be our R2. And then our R1 will be the radius of the planet. Right there. And we know that the initial energy should equal the final energy. Our initial energy is the kinetic energy plus the potential energy. And that should equal our final kinetic energy plus our final potential energy. Our initial kinetic energy is right with the launch, 1/2 mass times our launch velocity squared. Our initial potential energy is that for two stationary objects at a distance, in this case, of the radius of Rotan. So that's going to be negative g, mass of the planet, mass of the object, over R1. And that should equal our final kinetic energy, which would be 0 because we just barely made it out to that point, plus our potential energy at that point, which would be negative g, mass of the planet, mass of the object, over R2. We're not going to be in a stable orbit. We're just going to make it to that point at that height away from the center of the planet. Alright, if I look at this, all the masses cancel out, at least for the space probe. And so let's solve this for the final velocity. So I have now that 1/2 velocity squared is going to equal gm times 1 over R1 minus 1 over R2. Alright, so next multiply both sides by 2, take the square root. So my velocity is going to be 2gm 1 over R1 minus 1 over R2, all that square root. So that's going to be 2 times 6.67 times 10 to the minus 11 times the mass of the planet, 4 times 10 to the 23. And let's see if I have enough room here. 1 over R1, which is 2 times 10 to the 6, minus 1 over R2, which is 3 times 10 to the 6. All this square root. I figure that out. What do I get? (2,982 meters per second). So that's the velocity we need to launch with in order to achieve that height from the planet. It won't be a stable orbit, so the object will tend to fall from that point. But that's our velocity, 2,982 meters per second.